Hello everyone, my name is Carolina and I'm from Rutgers University. Today I'll be talking to you about private multi-group aggregation, which is joint work with Rafael de Rivera and Salim Rouaihib. Private aggregation has received a lot of attention in the literature, motivated by applications to federated learning and medical studies. And the main idea is that there's a server that wishes to compute the sum of values held by multiple users. These values can be anything from votes by these users or maybe gradients held by these users. The users want to collaborate with the server to compute this sum. However, they worry about their privacy, meaning they want to keep their values private. This has received a lot of attention in the literature, where methods either provide differential privacy guarantees by adding noise directly to the user's values, or information theoretic guarantees that mask the user's value using one-time path type of schemes. In many applications, users belong to different groups based on their race, age, gender, or political views, to name a few. And the server wants a finer aggregate of the population. So it wants the aggregate not over the whole population, but the aggregate for each group separately. This led us to define this variation on the traditional aggregation problem, which we call private multi-group aggregation. In the setting we consider, in addition to holding a value, each user belongs to a different group. In this figure, we show three groups represented in blue, green, and red. In general, we can have any number of groups. We assume that the server does not know to which group each user belongs to. And so, a major concern for the user is to reveal his group. So to summarize, a user knows his group and wants to keep it private from the server. So in our setting, there are n users that communicate with a single server. Each user belongs to one of k groups and also holds an integer value. The user knows his group and value, but the server does not. Our goal is to design schemes that allow the server to find an estimate of values per group, so the server ends up with a vector S of estimated sums. The size of the vector is equal to the number of groups k. The scheme needs to allow the server to find this estimate under privacy constraints over the user's groups, while keeping in mind communication cost of the scheme, because users can have limited bandwidth and capabilities. Therefore, for a scheme, we care about three things: communication cost, utility, and privacy. We determine the communication cost by the total number of bits communicated by all the users to the server. As for utility, it's the MSE, so let S hat be the server's estimate of the true sum S. Then, to find the risk of the estimator, we look at the normalized mean square error. The third metric we consider is privacy. Like we said before, we care about keeping the user's group private, but not necessarily his value. And to measure the privacy level guaranteed by a scheme, we use local differential privacy. So like I said, the user belongs to a group and wants to keep his group private. And for this problem, we propose a new interactive scheme, which we call the Query and Aggregate scheme, or for short, Q&A. The main takeaway is that our interactive scheme performs better in the high privacy regime when compared to simply adding noise like in randomized response. This is achieved by the scheme having a reduced communication cost per user. Q&A is formed of two stages, the query stage and the aggregate stage. So the user answers an assigned query instead of just reporting a noisy answer. The assigned query is completely independent of the user's values and groups. Therefore, it can be assigned offline or as part of the scheme agreement. We completely characterize the scheme's performance in terms of communication, privacy, and utility. What is interesting is that the communication cost is independent of the number of groups. For more details about our work and more precisely our new Q&A interactive scheme, I refer you to our paper and invite you to watch our 20-minute presentation. Thank you everyone for listening, and for questions, please feel free to ask or email us.